Yo, what's up, guys? Welcome to another live learning session on PyTorch. So I believe the last time we left off, we were playing around with the MaxPool2D layer and trying to figure out how this works. So I moved some code around since the last time I was streaming this because I was playing with it and then I forgot that I was recording something for the, I forgot I was recording something. So what I did was I moved this the learning rate, the batch size, and all of this stuff down or up into one block. A little bit burpy. Into one block so that it was easier to reset, basically. And then I uncommented out this and I tried it out once. So this is what we've currently learned. This stuff needs to be into, this stuff probably needs to be here. Yeah. Oh, actually, you know what? We should... So I didn't even pick this up earlier until I just looked at this code, but this should not say plot X. This should say epic list, and this should say accuracy list. Okay. Anyway, so earlier what we found out was that if we use a MaxPool2D layer and then we flatten it, we need to flatten it down so that we can get the linear layer correct. We get 64 by 676 if with a kernel layer of 2. So 676 is 26 squared. So what we're actually looking here is 26 times 26, whereas that is actually equal to this, and that's equal to this. And I believe that's equal to this. X 26, X 26. It's one layer. I believe this is not actually equal to that. K equals 3. I don't really know where this comes from. This is 2 to the 11 times 2 to the 3, so this is 2 to the 14. So this is, we're going to play around with the max pool a little bit to kind of see what happens here. So before we send it to the max pool, what we're getting in is we're getting 28. This becomes 26 by 26. So what we're sending in is a 28 by 28. So this comes out as 26 by 26 by 4. So this is 28 by 28 into that. Now this turns 26 by 26 by 4 into 64 by 26 by 26. And this is a 26 by 26 by 4 that turns into 26. But this is a 26 by 26 as a single layer. One sec. So this goes 26 by 26 by 4 times, well, actually, no, this is more than that. I think, well, wait, what is this? 64. Yeah, actually, that's right. It becomes 64 by 26 by 26. Is the input into this 26 by 26 by 4? What happens when we flatten it again? This 6656 divided by 64. What is 6656? Divided by 64 divided by 4. Oops. It's 26 by. This is 26 times 4 times 64. Yeah, I think that's right. Okay, so that's where the 256 is coming from. Where's the 8 coming from? I really got to figure out how this max pool thing works. Oh. Max put uses 2 times the padding. Are we adding any padding? No, there's no padding, so that doesn't matter. Minus the dilation, doesn't matter. What does it do with the kernel size? Kernel size -1, so dilation is typically 1. So the H input, so let's see. The function looks like this. I'm gonna post a picture. I wonder if we can actually open pictures in the screen. Mark down. Can I upload a picture? I wonder if I can upload a picture. So let's just type. No, okay, but I can probably add a picture into this and we can pull it up. Okay, so this is what max pooling does. MaxPool formulas, or yeah. So the HN in this case is going to be, I think it's 26 by 26, right? Can we see what comp2D's out is going to be? It should be in channels, out channels, kernel size. What do we do? Kernel size equals 3, so let's be 26 by 26. In channels should be 28 by 28. 28 minus the dilation is 0, the kernel size is 2. Okay, over the stride. Stride is the same as the kernel size, right? Stride is 1. Okay. So is this the same as the max pool formulas? HN plus 2 times the padding minus the dilation times the kernel size minus 1 over the stride plus 1. Yes, okay. So this will be 28 minus, there's no padding and there's no dilation. So dilation is 1. So 26 minus 1 times 3 minus 1, so 26. 28 minus 3 minus 2 minus 3 plus 1 is 26. Okay, so that's how we got the HN. How does this work when you do the max pooling layer? I'm quite... What is N? I feel like it should not be 26 by 26. So what we actually need is a kernel size of 1. If we do a kernel size of 1, then we should get 26 by 26 by 4. 64 by 26 by 26 by 4. So the kernel size should make it... Oh, sorry, this actually doesn't do that. This actually goes here. If you just do the max pooling, it does this. Okay, so here we can see what happens when we train this model with the max pooling and see if this gives us any better results. No, I think this is going to mess up here, so that's wrong. Okay, so we now have the model. Let's make sure that our model is correct. Max pool kernel size is 1. Yeah. Okay. Now let's train it. It's very strange that it starts at such a low accuracy. It's like 6% correct. Oh, 14. Okay. Well, earlier it was 6%. This is the randomization of hyperparameters in action. Pretty sure this is still not right, so I'm gonna stop this. Doing something here is not right. If this shows up again on Epic 2, then it's still incorrect. What did we do last time? Because last time it... Okay, no, this is correct. Okay, now this is right. I think I just had to restart the optimizer function because this one used... This one's automatic optimizer was the one that we had created before, so we need to reset the optimizer loop every time we train. So this is going to train for a while because it's going to be 40 things. So let's see, epic number 4. Yeah. So, but we can already see that we got a lot higher accuracy starting from just epic 5 with the convolutional neural network. But I'm going to come back to this when this is done training. I'm going to pause the video for now. Okay. So I'm back and the model has finished training. And we can see that our model was able to surpass our last couple models before Epic 25 very easily. I think the first one was in the 70s, and so that was like around 10, yeah, 9. And the next one was 83, I believe. The last one was 83. And that took a bit longer. About Epic 25 as well, similar. But Epic 40, we got to 84. So... you know, obviously this is not the ideal model, but we can continue tweaking the hyperparameters of the model to make it more more accurate over time. So actually what I'm going to do here is I'm going to, with size X. So what I'm going to do is I'm going to for layer, we're going to look at the sizes so that we can better understand how the max pooling works. Because we can look at this, but this is like a complicated looking formula. So we're going to look at the sizes of the model. X equals layer. So what we will do is we will do one like input thing. So we'll just do which data loader do we need? Train data loader. 0. Let's just see what that is. Oh, okay. Is it dot yield or is it yield? it yields, right? So dot next maybe. Train data loader. What does this do? Gosh. Get. Oh, you know what? Actually, we'll just do the first entry. We don't need the data loader. We can just do training data. Training data 0. Cool. We'll probably do training data 0, 0. Yes. Okay. So we will model. Oops, that should be code, not okay. Model training data 0, 0 dot width size. Oh, sorry, model dot width size. And this should built-in method of size tensor. Right. Okay, so it should do this. Okay, what happens in the end? Mat, it's 4 by 676. So we have an error here. And it's 27, 4. Wait a second. Oh. So initially, let's see what the initial input size is. 1 by 28 by 28. Okay. 4 by 26 by 26. 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 Flattens to 4 by 674. Is this supposed to be kernel size 2? No, I'm pretty sure we just did kernel size 1. Yeah. Oh, what's going on here? Oh, oops. Okay. Very interesting because this actually lets us run it. So, this is very interesting. Because it should flatten out to... Right, so there's actually no 64 here, right? So how does that happen after the max pooling layer? Okay, so this is something that we're going to post on Stack Overflow, and I'm going to ask about it. That's all I got. Don't know why this works like that. Okay, well, gonna find out, and I'll keep you guys updated. So, thanks for watching, and remember to subscribe. Peace out.